And then there's going to be two words that are stemming from a circle that's circumscribed and inscribed. Okay, so we've got to go through all these things first. All right, first thing, concurrent lines. And we're doing this because these words are going to be popping up quite a bit. All right, if you ever see the word concurrent or concurrency or anything like that in here, what it's in reference to with lines is just three or more lines that are intersecting at the same point. So that could be just a basic thing. It looks like that. It could be three lines intersecting at the same point. Where they intersect at, I'm going to read right here. That point's called the point of concurrency. So line for segment AB, segment CB, and segment EF would all be concurrent because they're all intersecting at the same point. And then that point O, for just the way this looks, would just in general be referenced as point of concurrency. We're going to have a couple words between today and tomorrow that give those points of concurrency specific names. Okay, and it's all going to really deal with, at least for today, what kind of circles we can draw in relation to the triangles we're looking at. That's going to be the whole circumscribed and inscribed part of it. So at the very least, for lines to be called concurrent, they have to be three lines intersecting at the same point. You can have as many as you want. You can have 100 lines intersecting at the same point, they're still called concurrent. You guys really aren't going to deal with more than three lines. All right? We have like that, a whole bunch of concurrent lines there.
Oh, wow.
I would never ask you to identify them with one like this, unless, you know, I just felt like a mess. Please do. Have fun. Go ahead. H. What H? H is a point. What lines are you going? I would say which line would be maybe concurrent line.
Oh.
H. H is not a line. It would be A prime and A sub 1, that line. B and B, C and C are all crossing.
Yeah.
What else crosses that H? It's like the name that point. That point doesn't go, I guess A double prime and O.
I'm lost.
There's a line right there.
Yeah, the prime is double prime.
The primes, guys, when you say prime, that's the ones up top, like that.
The little number.
Okay, that would be like a prime mark for me. So when I say double prime, like A double prime is this point, right? I wouldn't ask you this. Like, you guys aren't going to deal with more than three lines for this problem. Okay? So just understand that you don't have to deal with stuff that crazy with it.
Yeah.
I'd say at least for right, not for right now. It doesn't mean you're necessarily going to do it. I'm just not going to close down the possibility of having something like that show up. Okay? So just for today, I'm worried about it. All right. The next two words, circumscribed and inscribed. Okay, the top two drawings up there, the ones with the four circles. All right, those would all be examples of a circumscribed circle. Anytime you see that word in here, when they say a figure is circumscribed around another, that means that it's basically going around the outside of it. All right, and for what we're talking about here, when you do a circumscribed circle, that means that that circle is basically intersecting every vertex of it. Okay, a vertex, we've only really kind of dealt with that with triangles. The vertex is where the sides come together. All right, so it only touches it in those four spots. Like all these up here have four sides, so that means they have four vertices. So that means the circle touches it in four spots. And then essentially what we're going to be dealing with is going to be trying to identify radii in the circle. Okay, because you guys should have a basic understanding that if I drew that line in there, right, that would be a radius. Okay, because it's going from the center of the circle out to the actual circle. All right, and then you should kind of have an understanding from prior courses that if I drew in multiple radii, they would all have the same measure. Like if I drew one right there, you would understand that those have the same measure. Okay, and the things we're going to be looking for today is essentially going to be those segments, all right, the radii, but we're going to relate it into a triangle. So you'll see pictures more like the one down here. Now the one down here, in this case, the circle is inside the shape. It's inside the triangle. All right, so that would be an inscribed figure. So circumscribed goes around the outside, inscribed goes inside. And again, it only, if it's inside it, that means it's technically to be inscribed. It's inside in such a manner that it's only going to intersect with each side once. Exactly once, not more than that. So I couldn't just draw some four-sided figure and draw a circle like that. That wouldn't be inscribed. That would just be on the inside. All right, if you inscribed it, it would have to touch each side exactly one time. You would get something kind of like, something like that. Close enough. It's a circle, okay? Just agree with me. All right, so if you're trying to sketch them, guys, just draw a sketch. Don't worry about all the labels in there. Okay, it's going to tie more into what we're doing after this. Just kind of understand. Inscribe means inside, circumscribe means outside. And again, what we're going to be looking for and what we're identifying when we get there are going to be trying to find the radii. Because I know they're always going to be equal. Like down here, that's a radius, so is that. So those are equal to each other, kind of thing. If I drew one over here, that's a radius, so is that. They're equal. Okay? And that's going to be the big identifying factor of the stuff we're doing. All right, now, we deal with these words because there's going to be two words that we're dealing with that go with the points of concurrency. And they're going to be formed by using these two words right there, circumscribed and inscribed. All right? And they're going to be pretty important words, guys. They'll show up on the test. You need to know them because they'll be in directions. It's kind of the words that are going to pop up here in a second are going to tell you how to do the problem in a second. Okay? All right. Can I move past this, guys? So we need to sit. First thing, okay, the perpendicular, because we're doing perpendicular and angle, so perpendicular bisectors are first. Okay? Everything's up there right now. What it says is if I took a triangle and is everyone okay with the glare? I know there's some glare in there. You see? It's good. All right, so this first bit, what's going to happen with these is saying, if I took a triangle and I drew a perpendicular bisector with each side. So like I went to this side right here, found the midpoint, drew a line that was perpendicular to that side. I came to this side, and is that about the middle? I'm looking at it sideways, so is this the middle? Close enough? I don't know, you gotta tell me. I'm looking at it slanted, so I can't really know. If I found the midpoint there, drew a perpendicular bisector, wow, that's not perpendicular, is it?
That's very far from
Closer? Better? I'm gonna touch this. That's not the middle. Yeah, live. Alright, so if I went to each side and drew in a perpendicular bisector, what's going to happen is they're going to intersect at the same point. Hence, they would become concurrent lines, because there would be lines, there's three of them, they intersect at the same point, so they're technically concurrent lines. So that's why that word's going to pop up with the things we're doing today. This point where they intersect is a point of concurrency, but This word right here is a specific word or a more defined word for that point of concurrency. All right? So this point, when you have all the perpendicular bisectors intersect, that thing's called a circumcenter. Now, the reason they name it that way is that this means that this point, because this is a point, that point is the center of the circumscribed circle. Which means that if I see the situation arise, like if I'm looking at my picture and I look at the triangle and I see like, oh, there's a perpendicular bisector, there's a perpendicular bisector. That means that I can come in and draw a circle around it best I can. Close enough. All right? And I know that if I draw that circle around it, that would be a circumscribed circle. If I draw that around it, that point right there, since it's called the circumcenter, all right, that point, I know because it's named that, I know it's the center of the circumscribed circle. Okay? Now, the whole point of understanding that and knowing that is that if I went into my picture now and I drew in all the radii that would be like inside the triangle, all right, such as, such as if I drew this line right here, that would be a radius, correct?
Correct.
Is it? Yeah. That would also be a radius. That would also be a radius. Okay? So the way these things are going to be given to you, you'll see, like on your pictures, you'll have to identify there's a perpendicular bisector, right? And where these perpendicular bisectors intersect is going to create three segments that are the same. And the only reason they're the same is because they're radii for that circle that's going around the outside. And the only reason I knew that was the center of the outside one is to understand that that point where these perpendicular bisectors come together is called that. So you need to get these words kind of going together in your head. You need to get perpendicular bisectors of a triangle create a circumcenter. And then you need to understand, guys, circumcenter is the center of a circumscribed circle. That's what tells you how to do these problems, is the words that are in there. So you have to make sure you're absolutely familiar with these words all the time. And at the same time, you have to be able to look at the picture and recognize things like, that's a midpoint, that's 90 degrees, therefore it's a perpendicular bisector. Okay? All right, so like the first bit really is simply everything I marked off there is how you're doing like any problem with the perpendicular bisector. Okay? Like, and it's basically going to be the same as what it was yesterday, where you just find things that are equal. All right? So that's that for that one. All right, so these would be like your examples of things to do. Okay, so the problems, like I said, guys, the problem should not be extremely difficult. Okay, it's just a matter of whether or not they say this right here, even if that's not there. If I were to look at this picture, like if I were to look at this one right here, I would see that side is bisected and it's perpendicular. That means I'm working with it. So I don't technically have to say that. And probably on the test, I won't say it. The book might say it now, just getting the habit of doing it. But test-wise, I probably won't. All right, now the whole idea of them telling you that is, again, where these come together, that point right there, where all these perpendicular bisectors come together is called the circumcenter. Which, again, I said, look, the reason you understand that that's the center, the circumcenter, because if I drew a circle around the outside of it, right, every radius would be the same length. So I know that that side, that's a radius right there, correct? Mm-hmm. That's also a radius, so those are the same. Those are the same. So if I did this problem and I said, look, I've got certain measurements up there. It looks complex because it's got lines and points and they're all intersecting and going crazy. But if you recognize things like, hey, that's a perpendicular bisector, that's simply the center of a circle, then you can just say all those radii are the same. So if that's 12, that's 12. And how long is this one? 12. that be the answer that they're looking for? Yeah. They're not going to be any harder than that. But you have to be able to look at the picture. You have to be able to recognize what's given to you. You have to be able to recognize which circle you're going to draw. All right? Same thing goes with the one over there. These things are said, hey, these are all perpendicular bisectors. That point right there is circumcenter, which means I can draw a circumscribed circle around it. Right? And all the radii would have the same measure. What do you think the answer is to that one? What? 13? You guys agree? Think it's 13? Yeah, it is. Because PZ, there is a radius, so is PX. They have to be the same. That's the only way these circles will work out the correct way. Okay? You gotta get the vocab down though. Vocab is essential to this. Alright? You don't get the whole perpendicular bisector thing matching up with the word circumcenter. You're not going to be able to do these. It's just not going to happen. Right? So that's the first one. The second one, the angle bisector. Alright? The angle bisectors, where they come together. Again, these are still concurrent. If you were to go in triangle, and bisect every angle, they're going to meet at a common point there. Okay, so again, if all these angles are bisected, like if I sat down, constructed it, brought out a compass, protractor, all that stuff, and I constructed it, they're going to intersect at the exact same spot. Okay? That's just a known fact. All right? Now again, you read through it all, it says, look, the angle bisectors of the angles of a triangle are concurrent. Again, they're concurrent because there's 3 lines there. They're all intersecting at the exact same spot, hence that makes them concurrent with each other. And then at the end, I also say, look, that point of concurrency where they come together, which I'll put a label on it in a second, or you can tell me what letter you want it to be, is going to have a specific name, just like the last one did. Okay? The perpendicular bisectors created a thing called a circumcenter. Just said the reason they gave it that name is because it was the center of a circumscribed circle. This point right here where they come together, which, what letter you want it to be? What? Okay. Okay, that point right there is now called the incenter. That in the word is formed because that is the center of the inscribed circle of that triangle. So it means, again, for these problems, basically what I'm doing, like I said at the beginning, is I'm looking for radii, things that are the same. So that means if I inscribe the circle here, wow. Okay? I understand because of definition-wise and identification-wise, that point is the center of that circle. It means if I draw a radius there, there, and there, these are all going to be equal to each other. Okay? And again, the way these problems are going to go, just like with the perpendicular ones, maybe on the diagram or in the directions, it's going to mention either angle bisectors or perpendicular bisectors. In your brain, you need to get angle bisectors and this word going like hand in hand right now, and perpendicular bisectors and circumcenters. Because that's going to tell you what things to look for. All right? You don't necessarily have to do the drawing of the circle thing. Okay, it's not a big deal. But that will help you out in terms of solving some of the problems, or at least identifying which segments are going to be congruent. All right, because the problems, like the two I had up there with the perpendicular bisectors, these are going to be pretty much the same kind of problem. All right? Like these two. We'll do. So if I gave you these problems, like I'll talk you through kind of what the thought process needs to be, at least right now. I would say, okay, I like the one on the left where it says, find GD. All right, and like the things you need to look for right now will be angle bisectors, perpendicular bisectors, or mid-segments, because it's really all we've dealt with. And I would go in there and go, well, they got congruent marks here, they got congruent marks there, they have congruent marks here. Does that mean all the angles are bisected?
Yeah.
Yeah. So if all the angles are bisected, what did I just say that point's called? The what? The incenter. So again, that means it's the center of the inscribed circle. So if I drew a circle, I would see, like that would be an inscribed circle. And again, the whole point of drawing the circle would just simply to see that that's a radius, so is that, so is that. So if this measures 6, where do the other two measure? What's your answer there? 6. Okay? So then it goes here. How would I do this problem, you think? All right. Why? So how do you know? Go through it. Tell me why. You're right. Tell me why. How do you know these are equal to each other? You said they're radii, right?
Yeah.
I agree with that. But how do you know that they are radii of a circle? What tells you that?
Well, the two angles are bisected.
Yeah. And look, that's what you need to get at. You need to say, hey, I know these two are radii because look, these angles are bisected. They intersect at that point. And where they intersect, that point is called the incenter. That's the stuff you need to do. So if I ask you why or say explain, those are the steps you need to go about. All right, and it could be quick. You say, look, they're angle bisectors, that's the incenter, they're equal. You don't even really need to mention that the circle's going inside it like that. Okay, but that's the basis behind it. So if I solve this out now, what are your steps?
Oh, it would be...
Give me the next step down. Don't go
Okay.
4x equals what?
10.
10, so x is
2.5.
2.5. Okay.